So learning target 6.5 says I can write the formula for a hydrate using mole ratios. So we need to know what a hydrate is, how to calculate it, and know how to name it. So a hydrate is a compound that has water attached to it as part of its formula. So if we remove that water, you have what's called an anhydrate. So copper 2 sulfate pentahydrate. We're going to use these same prefixes that we used in covalent compounds. So copper 2 sulfate, we write the formula for that using our charges, so +2 -2. And then the way we say that water is attached is we use this little dot here. It means that water is attached. It does not mean that it's multiplied. Okay, so we have to make sure we get the symbols down. So that's what the formula looks like, 5 from pentahydrate. So if we have calcium sulfate dihydrate, we write the formula for calcium sulfate, which is CaSO4. We put our dot in there, and di means 2, so 2 waters get attached. So find the formula for a hydrate that contains 0.391 grams of lithium hexafluorosilicate and 0.0903 grams of water. So just like empirical formulas, we're going to need our mole ratios. We're going to convert grams to moles. We're going to use our molar mass. So for lithium hexafluorosilicate, here's our work. Here's the molar mass for lithium hexafluorosilicate. So 0.00251 moles of lithium hexafluorosilicate is what we get. Here's our work for water. So 0.00501 moles of water. So we're going to divide by our smallest. So 0.00251 is our smallest. So 0.00501 divided by 0.00251 gives us a 1:2 mole ratio. So that means we have 1 lithium hexafluorosilicate to 2 waters. So our formula, we write the formula Li2SiF6, put a dot to indicate that water is attached, and 2 H2O. So to name this, it would be lithium hexafluorosilicate dihydrate. Alright, in this problem we have percentages. So same thing, we're going to assume that we have a 100-gram sample and change those percent to grams. Whoops. Alright, so convert moles using molar mass. So 76.9 grams of calcium sulfite is 0.640 moles. 23.1 grams is 1.28 moles of water. So 0.640 is our smaller value here, so we divide. We get a 1:2 mole ratio. So we write our formula. We write the formula for CaSO3. Then we show that water is attached by putting a dot. And then our ratio is 1:2. So we have 2 waters. So we would name this calcium sulfite dihydrate. Now if you have a problem like this, where you have a hydrate, it has a mass of 13.52 grams, we're going to heat the sample until there's no water left. So then we have the anhydrate that has a mass of 6.6 grams. So find the formula and the name. So what we have to realize is that our hydrate has a formula that looks like this. Now we don't know how many waters are attached. And when we heat it, we separate our compound into magnesium sulfate and that number of waters. So if we know that we have 13.52 grams of hydrate, that's going to equal the mass of the anhydrate plus the mass of water. Okay, now this is a different X here, sorry about that. So our mass of water is 6.92 grams of water. So we're going to convert the anhydrate mass and the water to moles. So for magnesium sulfate, it looks like this. Notice we're using 6.60 grams for magnesium sulfate. For water, we use our 6.92 grams. So you get 0.0548 moles of magnesium sulfate and 0.384 moles of water. So when we divide by the smallest here, we get a 7, 1:7. So magnesium sulfate, got our dot, 7 waters, and the name is magnesium sulfate heptahydrate.